Hello and welcome to Maths Moments Mondays, bite-sized Maths PD by teachers and for teachers. Every week we get a new teacher to come in and show us something amazing that they're doing in their own classroom. So this week we're up to episode 7 and we are joined by the incredible Davin Kerr. Now, Davin is a specialist maths teacher, and this tip's going to be for the specialist maths teachers among us. Usually when you end up moving into 3 dimensions, equations of planes, equations of lines, students have trouble keeping their conceptual understanding in check. What does an equation of a plane really mean? What does it look like? Davin's going to use Geogebra here to visualize equations of planes and what the intersections of planes really mean. All right, take it away, Davin.
Hi, today I'd like to go through question 16 on the 2022 Technology Active paper. It's a good question. It's got equations of planes that don't intersect at a point, they intersect at a line. You can see the solutions there. I'm not interested in the Gaussian technique. I'm interested in looking at using GeoGebra to get a conceptual understanding of the solution and also the conceptual understanding of that line in the vector form when lambda equals -2. Okay, so what I've already done is I've already started creating our solution. So we've got our two fixed planes there and our plane with our parameter in it. And we can see here that when we move our value of lambda, okay, that moves as well. So when the solution says lambda equals -2, okay, we can quite clearly see that that's a straight line. Right, if we go back to the solution, we can see that one of the methods used gets this solution. So what we're going to do is we're going to plot this point, and we're going to plot this point and look at how GeoGebra we can show that line in GeoGebra. So I plotted the origin. The origin is very important. So I plotted that point A, so that the equation of the vector equation of the line is A plus KD. So it's quite sensible to call that point the fixed point A. And I'm also plotting this point D because it's the when we create a vector from the origin to that point, that's the point that we're going to get multiples of to join or to add on to A to create that line. So I've also created 2 vectors, so vector from O to D, we're going to call that D, and A from O to A. It's not clear there because of the colouring of those planes, but we'll have a look anyway. All right, so to get our line, we type in A plus TD. Okay, and we can see quite clearly that line does in fact form on the intersection of those 3 points. And the reason that we used the word lambda instead of the character lambda is because of this. I don't want to get that confused because they're 2 different things. Right, so what we're going to do now to see that we can get a whole set of points that lie on that line, we might get rid of our planes because we're not interested in those anymore. We're just really interested in that line and those points. We're going to set up a slider, so k equals 1, doesn't really matter what you start with. And then we're going to get a point, so all of our points are uppercase, so C equals A plus KD plus KD, and we can see that point over here, that point there, C. And we can draw a vector, so little c equals vector from O to C. Okay. And if we don't like the colour of that, we can change it. I'll change it to red just so it stands out. Right, and we can also show the value of that point by going there. Okay, and if we let k equals 1, we can see here that 2.25 plus 1 times 0.125 equals 2 or 2.375. So Geogebra rounds it up. So 2.25 plus 0.13 is 2.38, and you can see those other values going line there. So for our sliders, we can change it to 2 just if we want an exact value, and we can verify that there. So this is just what I like to use to verify my solutions. It's quite quick and easy once you get used to it, and it's a very valuable tool to get a very conceptual understanding of what's going on with those planes. So we can see all of our planes and our line goes up and down. Those points form that line that goes up and down where those planes intersect. Okay, hope that's useful.